While there are different approaches to setting up the Intercept, this demonstration shows a method that's a bit more efficient. Be sure to wear appropriate PPE, which includes gloves, preferably cut-rated, and safety glasses. The gloves not only protect you from cuts, but they also keep the oils from your skin from contaminating the spacer material. Verify the machine is in the manual mode, master start is achieved, and the continuous jog switch is in the on position. Having continuous jog on will cause all stations upstream to jog simultaneously. Using a pair of non-serrated tin snips, cut the material at the entry of the feeder press and gently drop the blue tensioner roll to the floor. Move the roll former touch panel towards the infeed end of the machine and cut the material close to the entry guide rolls, while grasping the end of the material on the feeder press side of the cut, as shown here. Jog the roll former forward while holding this end up, and both the feeder press and the roll former will be cleared simultaneously, provided the blue tensioner roll is held above the full loop sensor and the jog switch is pressed until the material stops moving on the conveyor. This saves time clearing each of the machines independently. Carefully pull the material from the exit of the feeder press and cut off. Watch that your fingers don't get pinched by a corner punch or cut on the sharp edges of the material as it's folded up and discarded. Navigate to the cutoff page on the roll former touch panel and unlock the hand wheel's electronic brake. The ring around the button is green when it's locked and red when it's unlocked. It is not typically necessary to reset the home position each time the machine is set up for a different spacer size. Simply change from the current position to the new set point. When doing this, always go a little larger than the desired size, then close down to the set point. This way you eliminate any effects of backlash in the Acme screw assembly. The cutoff set point for a spacer is the finished spacer width, which is the same value that will be used to set up the roll former. This value can be found on the material width table in the Intercept 2.5 instruction manual, IM 100, which is located on the machine's HMI under Help and Online Manuals. Go to the Index and Material Width tables and scroll down a couple pages to find the table itself. If you find it necessary to reset the width display, do so by closing the hand wheel until the dies just come together and stop. Back off the hand wheel slightly and close it again slowly until the dies just touch and a slight resistance is felt. Press the preset button, which establishes a home position for the machine. Then open the hand wheel slightly wider than the desired set point and close down to that value. Once the cutoff width is set, lock the hand wheel brake. The roll former and feeder press may be reset in the same manner if necessary. An indication that this may need to be done would be if the material is too tight or too loose when threading the material through the machine. Another indicator would be if the spacer quality checks used to verify proper machine setup are out of spec. These will be discussed later in this video. Navigate to the roll former screen and unlock the width adjust hand wheel. Adjust the hand wheel to the desired spacer size. Again, always open it slightly wider, then close down to the desired number to eliminate backlash in the Acme screw assembly. Lock the hand wheel. Move over to the feeder press and navigate to the feeder press screen. Unlock the width adjust hand wheel and change the width setting to the coil strip width for the spacer size being used. Again, open slightly wider, then close down to the nominal strip width. Lock the hand wheel. Using a pair of calipers, measure the width of the material strip and verify it's within the spec of +0 to -5 thousandths, as stated on the material width table in the instruction manual. See GED document ED19 for other material specs like material thickness, slit width, and burr allowance. For ultra stainless steel spacer material, and thin plate spacer material. Before we load the feeder press, let's identify the material sensors at the entry of the machine. The material sensor provides an input that material is present. The color sensor identifies if the material is silver or black, and the material type sensor distinguishes between thin plate material and ultra stainless steel. The dome light on top of the feeder press, as well as the display color, changes when different types of material are present under the sensors. The colors correspond to the labels below the dome light. Note, the colors for ultra stainless steel and thin plate have changed on the dome light from earlier models, but the display is not changed. The quick change die caps will change for the material types that are set. A material mismatch warning will appear for those that are not set up. Using a pair of non-serrated tin snips, turn the material upside down and cut the end squarely, and nip about 1/4 of an inch off the corners at 45 degrees. By turning the material over, any burr will be on the top edge of the material and will be less likely to jam or catch on the dies when threading it through the machine. Since the roller is on the floor, the machine sees loop 1 as a full loop. Therefore, it will be necessary to turn continuous jog off for a moment so that the uncoil can be jogged forward. Jog out enough material to feed through the loop control and feeder press. Generally, if you feed out enough material so that the material loops back on itself, that will be a sufficient amount. Turn continuous jog back on and thread the material into the opening on the entry of the feeder press. Continue to push the material until it hits the feed rolls at the exit end. Caution: to avoid being cut, do not hold the material by the edges. Rather, push the material forward against the cascade strip into the feed rolls. Bump the jog button briefly until it grabs the material. Continue jogging until the material exits the feeder press, then press the punch test button 4 times to activate each of the punches once. Jog the material forward until all the punches have exited the feeder press far enough that they can be measured. Measure the width of the parting area between the tab punches as shown here. This is the first of 3 quality checks that should be done to verify that the intercept is set up properly. This check verifies that the feeder press is properly set up. Compare this measurement to the parting width dimension on the material width table for that spacer size and tab type. Note, the punch depth of the tab will vary depending upon which type of tab is installed in the machine, which in turn affects the parting width. The material width table in the manual is for corner plus tab. If your intercept is equipped with the Sherlock feature, then the machine will be equipped with the Sherlock tab dies. The parting width of the Sherlock tab will vary to acquire the proper fit as the tab is inserted during the folding process. This is because the Sherlock tab depth controls the height of the tab, which affects the insertion of the tab over the Sherlock dome feature. If the insertion of the tab requires too much force, heavy fingerprints in the sealant could result. The purpose of the Sherlock is to help lock in the tab for proper hole alignment and should require minimal insertion force. Since the material width table for Sherlock is not in the user's guide, contact GED for a copy. The Sherlock material width table is a spreadsheet that calculates the parting width based upon the tab punch depth as set up by the maintenance technician. This should be printed and posted on the feeder press for operator reference. Also, traditionally the tolerance of the parting width has been the summation of the plus or minus 5 thousandths tolerance on each of the tab punch depths for a plus or minus 10 thousandths acceptance range. While this is normally acceptable for tin plate and thin plate spacer materials, it is too wide of a range for ultra stainless steel material. A plus or minus 10 thousandths tolerance is a 20 thousandths variance not only for the tab punch, but also for the corner and mutton punches. This is too large of a range for these punches. If this much variance exists, the corners on ultra stainless steel spacers would likely not fold correctly, and the mutton punch clips would also not fit correctly into the spacer channel. Therefore, the parting width of ultra stainless steel spacer should be no more than plus or minus 5 thousandths of an inch. In fact, this should be as close to the nominal value as possible, typically within a few thousandths of an inch for consistency and corner fold quality and crimper functionality. It is assumed that if maintenance is properly set up the machine, and if the parting width is good, So are the corner and mutton punch depths. Be sure to use the right material width table for the machine tab type, whether it be Corner Plus or Sherlock. If the measured parting width is only slightly off, the hand wheel brake can be unlocked and the hand wheel adjusted accordingly. For instance, if the parting width is 5 thousandths over the nominal value, the hand wheel can be closed 5 thousandths to correct the issue. Repeat the punch test to verify. If the parting width is off a considerable amount, then it is likely that the home reference position needs to be reestablished. To do this, clear the material from the press, close the hand wheel until the die is lightly touched, and press the preset button. Open the width setting slightly wider than the nominal strip width and close down to this value. Once the feeder press setup is verified and the parting width is acceptable, jog enough material through the feeder press to go under the blue roller and into the roll former. Guide the material strip between the roll former entry guide rolls and the guide plates up to the first set of rolls. If the material is too wide to go between the guide rolls, or if it's very loose, this would indicate that the home position needs to be reset. To do this, remove the material from the guide rolls, unlock the roll former with hand wheel, close the roll former until the rolls just touch, and press preset. Open the roll former width slightly wider than the nominal spacer width, then close down to this value. As with the feeder press the material strip against the cascade strip towards the entry of the roll former. Press the roll former forward jog button until the material feeds into the first set of rolls, then let go of the strip. Continue to jog the material past the first few roll sets, then move the touch panel towards the exit end of the machine. Hold down on the pacer encoder and continue to jog the roll former until the material exits the machine and passes over the encoder wheel. Stop jogging, gently release the encoder wheel, and lift slightly from the underside of the spacer while continuing to jog, ensuring that the material passes through the cutoff without any issues. Readjust the conveyor hand wheel until the guide plates are slightly wider than the spacer. This is particularly important on narrow spacer sizes, as they tend to fall over on their side. Earlier it was mentioned that there are 3 quality checks that the operator should perform to verify that the Intercept spacer frame machine is properly set up. The first is to check the parting width to verify that the feeder press is properly set up. The second check is to measure the spacer width, verifying that the roll former is set up correctly. And the third check is to measure the width of the switch tab to verify that the cutoff is set correctly. These checks should be performed anytime the spacer size has changed and upon machine startup. To check the spacer width and the switch tab width, it will be necessary to run a few test spacers. At the HMI, or Human Machine Interface at the main control panel, choose the production option at the bottom of the screen and clear the queue if populated. Press the MDI button for manual data input and press the Clear All button to remove any spacers that are already in the schedule. Enter a spacer size of 12 inches wide by 12 inches high. Then select the spacer size being run, and then add 10 spacers. Select Run Next, then from the production screen, press Start. After a slight delay, the machine will start to produce spacers. Remove the thread-up material from the conveyor once it is cut off, and press the feed hold after a couple spacers have been produced. Using a pair of calipers, measure the width across the bottom of the spacer. The width has a plus or minus 5 thousandths tolerance. Here we're only 1 thousandths oversize, but well within the tolerance, so no adjustment is necessary to the roll former width. If the spacer width is not within specification, the material will have to be cut at the entry of the roll former, cleared out, and the width adjusted accordingly. Never adjust the roll former with material in the machine. If the spacer width is marginally off, open or close the roll former by the difference in width from the nominal value to the correct roll former setting. If the roll former is off a considerable amount, then close it all the way and press the preset button to establish its home reference position. Rethread the machine, run a few more spacers, and check the spacer width again. While measuring the spacer width across the bottom, zero the calipers and measure the tab width. It should be 30 thousandths less than the spacer width, plus or minus 5 thousandths. If it is not within this range, calculate the difference from 30 thousandths. Navigate to the cutoff screen and unlock the hand wheel and adjust the hand wheel accordingly. Say for example the tab measures 40 thousandths narrower. That would indicate that it is being swedged 10 thousandths too much, so you would have to open up the width 10 thousandths. Remember to open a little wider, then close down to the new set point. Relock the brake and release the feed hold. Run 2 more spacers and press the feed hold. Measure the tab width of the second spacer to verify that it is now within specifications. Repeat this if necessary. Once within specification, place the machine in the manual mode on the touch panel to stop the schedule. The machine is now properly set up and production can be run.